Greetings, fellow mathematicians! We're going to take a look at another problem on finding points on a curve where the tangent line is horizontal, and at the same time, we're going to continue our review of algebra. Now, from the previous three problems, we know what to do. We're going to calculate the first derivative and then set it equal to 0. And that gives us an equation, the first derivative equal to 0, and we're going to solve that for x. All right, now let's get right to the work here. The derivative, that's going to be simple to calculate. We basically just need the power rule. So if we write down our function as f of x, which is x cubed, minus 3x squared minus 12x. No problem to calculate the first derivative. If we go ahead and apply the power rule, bring the 3 down, we'll get 3x squared. Next, we're going to bring the 2 down to get minus 6x. And a derivative that we've used a lot, the derivative of x, that's 1. So here, the constant multiple, we get this derivative as negative 12. Negative 12 times 1, 1 being the derivative of x. All right, that seems straightforward. That looks like some other problems that we've solved. We're going to go ahead and now take the derivative and set it equal to 0. And that turns the calculus problem into an algebra problem. So the equation that we're going to be solving is 3x squared minus 6x minus 12 equals 0. And we're going to maybe attempt to factor that. And I'm going to notice I can pull out a greatest common factor of 3. So we're going to get 3 times now x squared minus 2x and then minus 4. That equals 0. And if we were to go further and try to factor what's in the parentheses, we would need to find numbers or integers that multiply to negative 4 but add to negative 2. And there are no numbers that satisfy those properties. This part in parentheses doesn't factor. So what do? We're going to set this equal to 0. X squared minus 2x minus 4 equal to 0. But it doesn't factor. In this case, where you have a quadratic equation, you can use the quadratic formula. And as a student in Calculus 1, the expectation of your professors will be that you are comfortable and aware of using the quadratic formula. Now, I've found that many Calculus 1 students maybe forget about it. Maybe they didn't use it much or at all in their pre-calculus course, but that's okay. Make sure you realize from this problem, you want to be aware of the quadratic formula. So let's go ahead and write that down. Hopefully you know it. If not, we're going to review it right now. All right, and we're going to write it in the standard way. The quadratic equation that we're going to be solving is ax squared plus bx plus c equals 0. And the quadratic formula gives you a formula for the solutions x in terms of the coefficients a, b, and c. And that comes out x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, and that's really the key to this problem. Here, the equation looks very much like other ones that we've solved by factoring, but it doesn't factor. I always tell my students, if you can't factor something in about 30 to 60 seconds, just give up and use the quadratic formula anyway. That's always going to work, and the calculations are really quick. So let's go ahead and identify your coefficients of a, b, and c. You can identify them from up here, but they're going to be a little bit bigger. A, b, and c up here are all greater by a factor of 3. The calculations will be easier if we divide 3 off and identify a, b, and c from here. So let's go ahead and write that down. We're going to have a, the coefficient of x squared, that's 1. B, the coefficient of the x term, that's negative 2. And c, the number just by itself, that's negative 4. All right, at this point, it's a plug and chug problem. Just plug your values for a, b, and c here, and you'll get your solutions for x. And those x values, those are the x coordinates where the tangent line is horizontal. All right, let's just take our time. And I'm going to do some simplification that's standard in a Calculus 1 course. The formula is negative b, but b is already negative. We know that's going to cancel to become 2. We have plus or minus b squared, so square negative 2, that'll become 4. And we have minus 4ac, but c is negative, so that's really going to cancel to give you a plus. And if we multiply a times c, that'll come out to 4. 4 times 4, that'll be 16. All right, and in the denominator, that's going to be dividing by 2a. So here, just dividing by 2 times 1, or 2. All right, we're just going to take our time and simplify that. Looks like in the square root, we're going to get the square root of 20. So we'll write the numerator here as 2 plus or minus the square root of 20 over 2. And that would suffice as an answer, but we can actually simplify it. We can take square root of 20, and even though 20 is not a perfect square, some of its factors are. Let's go ahead and write 20 as 4 times 5. And if we take the square root of each part, we'll be able to write square root of 20. We can write that as 2 times square root of 5. So if we go ahead and plug that in, we get 2 plus or minus 2 times square root of 5 all over 2. And you can even go one step further. Notice you can divide the 2 in the denominator to each factor or term in the numerator. And if you go ahead and do that, 2 divided by 2 will give you 1. And then divide 2 to the other term. The 2's will cancel out, leaving with just square root of 5. And that is it. So what we find here, due to the plus or minus, there are 2 values of x for which the tangent line is horizontal. If we just go ahead and write them down, one value for x is with the positive, 1 plus square root of 5, and the other is with the negative in between. Now you can take these x coordinates, plug them back in to your function to get the matching y coordinates, completing the answer here as a point or ordered pair, but it's not going to come out to anything nice. So that's probably a really nice form for the answer. These are the exact values or exact x coordinates of the points where the tangent line is horizontal. And again, you can just plug in those x values to get the y values if needed. In my Calculus 1 course, I would have my students just leave it as that. Hope you enjoyed the problem and the brief review of the quadratic formula. From this problem, you should expect, moving forward, to be comfortable and familiar with the quadratic formula. Hope you're learning a lot from the videos. If you are, support the channel, like and subscribe.